Alright, this recording is to help you with lesson 6.03, vectors in the plane. Alright, we're just going to start out with your adding, subtracting, and multiplying by a scalar. It's really nice because it's just like adding like terms almost. So if you have u plus v, we want to add those vectors together. So 1 plus 3 is 4. And then 2 plus 1 is 3. And subtracting them, the same idea. 1 minus 3 is negative 2. 2 minus 1 is 1. And then with the scalar, it's just like you think. We're going to multiply the first numbers by 2 and the second numbers by 3 and then subtract them. So really u becomes 2, 4, and v becomes 9, 3. So when we subtract them, 2 minus 9 is negative 7. And 4 minus 3 is 1. Okay, we're going to find the vector v with the given magnitude and the same direction as u. So to find the vector v, we have this equation here where we take the magnitude times 1 over the magnitude times your vector, which is that direction there. So 5 times 1 over, and remember to find this right here, we take 3 squared plus 3 squared. So that's really finding your length of your vector. Excuse me. Okay. And then we're going to multiply it by the direction. So this technically maybe should be a u here. So we have 5 over the square root of 18. And we're just going to simply simplify that square root of 18. So that is 3 times 2, or 9 times 2, so 3 square root 2. And then we can distribute that. We are going to leave the square roots in the denominators here. So notice that the 3's actually cancel out here with each other. So you're just left with 5 square root 2. 5 square root 2. These are not parentheses. I want you to note the direction of vectors is actually like these arrow type things. They're not parentheses. So make sure your final answer is not in parentheses, but yet in those arrow type brackets. All right, next, let's just find the magnitude and the direction. Well, your magnitude is always that number out front of your parentheses that you're multiplying by. So in this case, our magnitude is 5. And then the direction is always a point, and in this case, 30 degrees is a point, right? So here is the 30 degrees is your direction. Remember, well, last time we had to multiply through by a point type thing. How come we're not doing it here? 30 degrees is a point. So on your unit circle, you do have an x and a y coordinate for your 30 degrees. So you have to think about it that way. So here, 30 degrees actually is the direction you're going. So if you want to think about it that way, 30 degrees is about that far out. So that would be your direction, is 30 degrees. Okay, find the component form of v given its magnitude and the angle it makes with the positive x-axis. Sketch v. Okay. We have this direction of I plus 3j, which is really like your 0.13. Okay, so we're thinking it that way. Let's find the actual vector here. So we're multiplying by the magnitude. So 2 over the square root of your 1 squared plus 3 squared, so that's 10. And you have your I plus 3j, your direction. Okay. So here, what they actually did is they did not keep the square root in the denominator this time, so they did simplify that to get 2 square root 10 over 10. And 2 over 10 is the same thing as 1/5. So that's how they got the square root of 10 over 5. We have that times I. And we'd have that same thing, only when we multiply it by 3, that's what we get. So technically, we can have this in component form, or if we want to write it as an actual vector here, we would just take those values in front of the I and j and list them there. Okay, to finish things up here, we're going to actually use the law of cosines to find the angle between the given vectors. I don't know why they just don't use theta. It's probably easiest, but that's okay. I forgot what Greek letter that actually refers to. I'm kind of drawing a blank there. All right, let's find the magnitudes of each of these. So we have ij, so that's a 0.11. So 1 squared plus 1 squared is the square root of 2 for v, the vector or magnitude of v. For w, we have 2i minus 2j. So that's 4 plus 4, so that's the square root of 8. And I'm just going to leave it as the square root of 8 for now. And then u, in my picture here, is actually v minus w. So when I subtract those, v minus w gives me the point 1 minus 2 is negative 1, 1 minus 2 is negative 1, 1 minus negative 2 is positive 3. So it gives me the point negative 1, 3. So the magnitude of that is negative 1 squared plus 3 squared, which is your square root of 10. Okay, now that we have all those magnitudes, we can refer back to the law of cosines here. So cosine of your angle equals your vectors squared, so v squared plus w squared minus u squared, all over 2vw. So because you're taking the squared, your square roots disappear. So you're going to have 2 plus 8 minus 10. And then the denominator, you can write those in. But really, in the numerator, we notice that 2 plus 8 minus 10 is 0. So it doesn't matter what the denominator is, because your answer is automatically 0. But that's not a degree measure. Remember, we're looking for the degree measure. So we have to do cosine inverse of 0. So that last step gives me the 90 degrees for that angle in here.